Find the size of the unknown angle in the diagram below, in other words, this one over here. Now, in order to do this, we need to add some extra lines to the diagram. If you haven't seen this done before, it's unlikely that you would come up with this. So the center of the circle is here. What I'm going to do is I'm going to add in those 2 radii. Then because that's a radius and this is a tangent, we know that this is 90 degrees. That would make this angle here 32 degrees. Because we have an isosceles triangle, that would make this one 32 degrees. And that would make this angle here, using the 3 angles of a triangle, 180. Take away 2 times 32. So that one would be 116. And then, because what we have is an arc just here, and the angle at the center and the angle over here both stand on that arc, this one at the center, this one at the circumference, and therefore that's half of the 116, which is 58 degrees. So note that that's equal to the original angle that we had. This is actually a theorem called the alternate segment theorem, and you would prove it doing exactly the steps that I've just done. What we would do in that case, though, is this angle would be called x or theta or alpha or something, and we would go through the steps algebraically and show that this one over here is also x.